All right, and we are live.
Fantastic. Well, welcome everyone to another edition of Community Office Hours with Terraform. Today, we're going to be talking to Areet and Phil about Kubernetes and Helm providers. We're going to be talking about Kubernetes Alpha, the Terraform cloud operator for Kubernetes. There's just a whole host of things to talk about, all of which I'm quite excited to have both of you on the show to talk about. So with that, would love to turn it over to you to introduce yourselves, starting with Areet.
Sure, thanks for having us, Taylor. I'm Arit Mahadevan. I'm the engineering manager for what we call the strategic integrations team on the Terraform platform. So we handle providers and other integrations that are considered strategically important to Terraform.
Hey, and yeah, thank you, Taylor. So my name is Phil Sautter, and I am sort of Arit's co-conspirator here. I am the product manager on the strategic integrations team, and these are actually just a subset of the products that we're working on, but they're really important to us, and we're really excited about them.
Awesome. Thank you both so much. With that, would love to kind of jump into a few topics that we've prepared for you today. One of which is that the Kubernetes provider and the Helm provider, but we'll get to that in just a second, just recently reached version 2.0, and wanted to ask both of you, what were some of the considerations thought on before reaching 2.0? Can you kind of give some of the backstory there, as well as some of the new features that are out in 2.0 and kind of what that overall focus is on at the current point in time?
Sure, so I'll start with this one. So when I joined HashiCorp about a year ago now, and started working on the Kubernetes provider with Areet and the rest of the engineering team. And one of the things that was really important to us and to me was to get really a feel for what the practitioners, the users of our providers were going through. And so I set up a lot of user interviews to speak with many of you. Hopefully some of you that I interviewed are actually here watching this today and can see some of the outcome of those interviews. But I was able to learn a lot about how people, how companies and different organizations were using Terraform and Kubernetes together. And from there, we were able to draw some conclusions about some areas of the provider that weren't necessarily serving the bulk of our community, very well. And specifically, one of those areas that really came through was authentication and authorization within Kubernetes and the Terraform provider. And we saw this on the GitHub repo as well. But it was really crystallized in talking to you and hearing about the process that you went through for all of these things. And so that was really one of the main focuses of the 2.0 version of the Kubernetes provider. So Areet, I'll let you chime in there as well.
Sure. So, one thing also I'd like to highlight, just a little insight into the way we do things, I guess, in the background, is we like to approach our backlog from a thematic perspective. So we go through, we review the issues that you all submit in our backlog, both bugs and feature requests. We discuss them once a week, and we talk about, what can and can't be done for each issue. We log that information. And then we have a separate meeting where we sit and review all of those logs to think about, okay, what are some themes we can extract here in terms of the effort we want to put in? And so for the 2.0 release, a couple of the themes that we pulled out were authentication, like Phil said. We also wanted to make sure there were a couple of issues where our provider behavior wasn't aligned with the Kubernetes API. And so that was a theme we pulled out to say, we want to make sure that the resource configuration experience, aligns with Kubernetes so that, it's consistent across the board. And so if you look at our upgrade guide, I actually have a link here I can drop into the chat. It outlines kind of the work that we've done for this release. There are several different pieces, but I guess the themes you could pull out are authentication, alignment with the Kubernetes API, consistent wait support. So we have the ability to wait for certain conditions per resource. And so we've aligned those. It used to be that some resources would wait, other resources wouldn't. And so now we've aligned it so they all wait unless otherwise told not to. And probably the last piece is that the SDK upgrade that we went through to the new plugin SDK means that we've dropped 0.11 support, Terraform 0.11 support.
Yeah, thanks, Areet. And just to add to that, right? If you're in, sort of software engineering, software development, you're probably familiar with the methodology and versioning and all of that. But to put a finer point on that, right, is we're constantly enhancing these providers, like the Kubernetes provider and the Helm provider, and we're adding new things in there in the mainline release, right? In the major release, we're releasing them as minor updates and patches. What we really focused on for 2.0 were these breaking changes, right? Redoing authentication, right? Redoing some of the default behavior of the provider. So it is really important that you go out there and read this upgrade guide, because the 2.0 version and beyond, right, will behave differently in several aspects than the 1.0 version.
I think that was the biggest thing for me when kind of updating some of the code that I had working with Kubernetes clusters, was setting that config path and just some of the other options I had available to me to authenticate with my cluster. I thought that was really helpful to kind of, like you said, read through that guide and kind of get a sense as to what was going on. I did see one issue that popped up a few places like Reddit and some GitHub issues, and just kind of wanted to ask you on that front as well, with regards to basically setting up and configuring your cluster versus, like if I were to upgrade my cluster as an example, and then configure it, I saw that it was better to break that up into different modules, and that being something that was kind of working its way through the community as a good kind of learning opportunity.
Yeah, it's great that you highlighted that, Taylor. So this is something that we consider a best practice. Many of you tell us constantly that you want to be able to apply or create a Kubernetes cluster and then apply configuration to that cluster in the same apply, right? And what we've found is that while this can work, there are many edge conditions that can cause trouble with this kind of configuration. And this is due to sort of the way that Terraform itself behaves and its dependency mapping, and not something that we can really control at the provider level. And so our recommendation has been, if you are going to try this, at least break the Kubernetes configuration out into its own module so that you can do a targeted apply if you end up in a situation where this no longer works for you. Because we find that quite often is you'll start with a simple configuration, you'll apply it all, it works, you're like, great, and then you start building on top of it. And then one day you come in and then it just doesn't work like you thought it was going to anymore. And so if you break your Kubernetes configuration out separately from your cluster provisioning configuration, even if you're not doing them in separate applies, if at some point in the future you can start doing targeted applies and only apply to the module that you need to, and you'll find that this is I think you'll find it's a much more supportable way to scale your Terraform code when you're using Kubernetes.
That's a great point, and I think that's really helpful to share that out. I've seen a lot of teams, start their Terraform journey, their infrastructure as code journey, and have everything together, whether it be a giant Terraform.tf file itself, and then kind of everything kind of starting like a monolith and then breaking out into microservices. And I've also seen that abstraction is being very helpful in determining or implementing, say, a network, basically creating that layer and then configuration for that layer, and kind of being pragmatic about ways to break up how you declare your infrastructure. And I think that that's really an interesting pattern that's emerged. That kind of reminds me of, for those in development, contexts, and basically creating all that business logic in its own module and then putting that into the right, REST endpoints, things of that nature. But kind of fun to see, those microservice patterns get applied into infrastructure as code. I think that's pretty fun.
Yeah, that's awesome, Taylor. One other thing I want to touch on while we're talking about this, because this is actually part of that story, is that it's part of the whole story with 2.0, as well as our recommendation to break things out, which is like, especially if you're using one of the major cloud managed service Kubernetes offerings, EKS, AKS, GKE, they use tokens that refresh periodically. And the best way to authenticate when using these tokens is to use, they actually have binaries that go and fetch these tokens, and there are other ways you could do it as well. But the Kubernetes, your kubeconfig, as well as the Terraform provider, provides this configuration called an exec block that allows you to leverage that pattern for refreshing your token. And so when you do that, if your token were to refresh, for example, in the middle of your apply, if you're using this exec block, it'll pick that up. If you have statically defined that token, or perhaps you're using a data source to fetch that token, right, you could run into a condition where the token expires in your middle of your apply and your apply fails. So this is a more consistent way to authenticate against those endpoints.
That's awesome. That's awesome.
Yeah, the only other call out I would add here, Taylor, is that one of our engineers, Steph, has actually gone through and added a bunch of examples to the Kubernetes repository that you can refer to for each of the major clouds, and how if you did want to, you know, do the cluster configuration and the Kubernetes configuration, the same apply. We're trying to give you a few patterns that include the exec block to help out.
That's awesome. I feel like we'll be able to make a Terraform quilt with all the patterns that we have at some point in time. One thing that I've also kind of seen in the community are there's a lot of talk about manifests and different providers for that. Obviously, my favorite, biased, of course, but my favorite is the Kubernetes Alpha provider for declaring those manifests and kind of getting everything instantiated into my Kubernetes cluster. Could you tell us a little bit about, you know, plans for the Kubernetes Alpha provider and kind of what the roadmap for that looks like as far as integration goes for, you know, all of the Terraform providers and how those are going to be integrated?
Yeah, fantastic question, Taylor. The Alpha provider, as we call it today, is something that, you know, the whole team is really excited about. It really unlocks a lot of potential and opportunity for Terraform to interact with Kubernetes. If you're not familiar with it, I would highly recommend you go check it out. It's the Kubernetes Alpha provider. You can find it on the Terraform registry, but it is a manifest analog, if you will. It allows you to represent your manifest in HCL, or you can frankly just pass it in your existing manifest using the YAML decode function that's built right into Terraform. So it's really flexible in that way. And actually, we're working on our next release, which, you know, knock on wood, is coming very soon. And I've been testing it out, and I'm really happy with a lot of the improvements to this next release. Mainly, we pulled back on the server-side apply that we were doing. So before, we were using server-side apply during the plan and apply phase for Terraform. Now we're only using server-side apply for the apply phase, and we're doing what we call local planning, which means we're still actually going out there and we're inspecting the Kubernetes Swagger doc to make sure that what you're planning is appropriate for the cluster that you're planning against. But we're not using the dry run feature for server-side apply to do that. And that was causing some dependency issues when you would create a configuration that had multiple dependent resources. The Kubernetes cluster wasn't able to see the future the same way that Terraform was, and so it created some inconsistencies. So super excited about this. Arit, I'll let you take it from there.
Yeah, thanks, Phil. Not too much to add other than maybe a look into the background again to show you a little bit of what we've been doing. Part of the reason we've been working on this separately from what's been published online in the OSS repo is because we've been trying to integrate the new plugin SDK into the Alpha provider, whereas before we were just bypassing the SDK in order to make this setup work. And the reason that it's exciting that we have this new SDK is that it gives us the ability in the future to potentially have the official provider have support for these CRDs. But in the meantime, Phil, I'm not sure if you were planning to talk about this later, but in the meantime, you know, we have some short-term plans for the Alpha provider.
Yeah, thanks, Arit. I was actually remiss for not touching on that. So this is actually an area that I would like your feedback, not Arit's feedback, but you, the viewers of this. So right now, the way the Alpha provider works, and if you are familiar with Terraform, you may have sort of heard this or may have piqued your interest when I said it, is that the alpha provider actually requires an existing Kubernetes cluster in order to plan, right? And so this is different than the Kubernetes provider. The Kubernetes provider can plan in isolation. It doesn't need to interrogate a Kubernetes cluster to determine whether the configuration is appropriate. So what this means is what we were just talking about before, right? People want to be able to create a cluster and configure that cluster in the same apply. Well, obviously, if your cluster doesn't exist, the alpha provider cannot plan because it has to interrogate that Swagger doc. So for the time being, we're looking at how do we graduate the alpha provider into its own distinct provider. And it won't likely be called the alpha provider, right? That'll be its incubation name, and we're looking for another name. We had originally planned to do what we call mux. We're going to mux it into the Kubernetes provider and provide a single sort of UX for Kubernetes. But with the plan time requirement for an existing cluster, we're afraid of breaking that. I don't want to say afraid. We don't want to break that workflow for those that are using it. But this is something that I want your feedback on, right? So please, if you feel strongly one way or another about whether the Kubernetes provider should have that plan time dependency on a cluster, or whether that would break your workflow, please come tell us on the Kubernetes Alpha Provider repo. I'd really like to hear from you on that.
Phil, I think he has a, sorry to interrupt you, Taylor, but I just wanted to say Phil has a pinned issue on the repository requesting feedback, which I think also has a Calendly link if you'd like to talk about it more in detail.
Awesome, thank you both. There was a question kind of asking about the alpha provider, and then they followed up with a jinx. So not sure who owes who a soda, but we'll figure that out after the stream. I'm really excited to get more into some CRD use cases and operations within my Kubernetes clusters. I know that before we've worked with the Domino's provider for Terraform, so if we can integrate pizza or tea, I think there were a couple espresso makers that have APIs that some of our coworkers have talked about. So who knows, with CRDs, anything is possible. The Helm provider did just get bumped up to version 2.0 as well. And really, is that kind of is that basically the same type of concerns that were addressed there? I did see that there were ways to authenticate with Kubernetes. Are there some interesting aspects to that aren't readily apparent as well?
Yeah, so the authentication changes are identical. Or they should be identical, right? That's the goal, right? Is to provide this consistent user experience for authorization. I'm sorry, for authentication and authorization across the various Kubernetes providers. The thing that we did do in the Helm provider that was interesting is the Helm provider used to have one data source and one resource. We had deprecated that data source a while ago. That was the Helm repository data source. So now it is a single resource provider. It just has Helm release. Some people even call it the Helm release provider when they're talking to me, understandably. The reason that we got rid of that is that we found when you were wrapping Terraform with some kind of automation like Terraform Cloud, Terraform Enterprise, right? The way that the Helm repository data source worked, if you were splitting up your environment between a plan environment and an apply environment, would cause issues because it downloaded the chart during the plan time, but then it wasn't available during the apply time. So we fixed this, right? And we just have the Helm release resource do all of these things, which works much better when you're running it in sort of some kind of CI environment. Arit, did you have anything to add there?
No, I think that covered it, Phil. And we're deprecating 0.11 in this one too.
Awesome. Thank you both on that front. There was a question that we got around what do you find is the best practice way to manage the user account that performs Terraform apply that provisions the cluster, specifically for an AWS use case? It's my understanding that the IAM user that creates the cluster maps to system masters cannot be viewed or changed in AWS auth config map. Try to say that 5 times fast. So it sounds mostly about kind of like access management with EKS on AWS.
if I can read into this question a little bit, there is the AWS auth config map that is created during the cluster provisioning in EKS. And one of the requests that we've had quite often is, I want to change, I want to modify, I want to remove this config map. This config map is actually, this is a misconception, I think. This config map is not there by default in EKS. This is created by likely a module that you're using that you've taken from the Terraform registry. And with that knowledge, you can actually go in and modify the AWS auth config map. In fact, you can create it yourself, however it works for you. And that is what I would recommend, right? Go into the module that you're using to provision EKS, look at how it's creating this config map. If that doesn't work for you, pull it out of that module, right? Fork that module, pull it out of the module, and put it into your own Terraform configuration in the pattern that works for you.
Awesome. I think that was one of my personal big hangups, is kind of getting into the ecosystem and trying to understand, how some of these things were mapped together. And then also when I stood up, I believe my first EKS cluster and tried to share that out with team members, and they weren't able to access it, and then kind of figuring out how to actually go about mapping those items. I thought that was a fun lesson to learn. Thank you very much. One other question that we got was, so basically as it is working now, you should use the case provider or Kubernetes provider to create clusters, and then use the Helm provider to configure the clusters. And short answer to that is yes, that's the best way to do it. Like Phil had said, it's best to separate the cluster creation with the cluster configuration so that you don't run into issues when you do a cluster upgrade, or if something gets changed in there that causes kind of like a domino effect of updates.
Yeah,
oh, go ahead, Areet.
Just wanted to say, I just also want to call out that that applies to the K8s provider too. So you don't want to you want to separate resource configuration where you're using the K8s provider for both cluster provisioning and as well. Oh yeah, actually.
Yeah, no, that's great. So there's just one bit of nuance I want to point out here, right, is the Kubernetes provider does not create Kubernetes clusters. It is agnostic to the Kubernetes cluster. It configures Kubernetes clusters, right? You create namespaces, you create secrets, CRDs, right? All the standard resources that you know and love from Kubernetes. It's going to be that you're going to create the cluster with either the AWS provider, the Azure provider, the Google provider. There's a kind provider, right? There's modules for Typhoon. You could use that to create your cluster as well. I looked at this a while ago, but I think that there were over 20 or 30 providers in the Terraform registry that could create a Kubernetes cluster for you in a given environment, right? There's so many cloud environments, there's so many managed Kubernetes offerings, there's so many standalone Kubernetes offerings, and Terraform really has just a tremendous number of ways to provision Kubernetes clusters for you in the appropriate environment for you.
I second that. It's really nice to like with any kind of compute, whether it be Google, Amazon, Azure, and your favorite cloud. Insert your favorite cloud here. When you talk about compute or storage, there are just so many considerations to think on. Even when you're standing up your worker nodes, and those working groups, whether it be an auto scaling group or something else in Azure or GKE. Once you get that configured, then we can start to kind of talk in that same language and that same configuration. Kubernetes makes it really easy to translate across all of those clouds, but like Phil said, only if you're actually able to get that stood up in that place that you intend. So great questions. There's one question around the best ways to pass values to the Helm provider. I know that you have the ability to use set and set secure. So that you can kind of set just in plain text, so that you'd actually see that echoed out and something that's usable, and then output or will get echoed out in the logs. Set sensitive, which is going to kind of mask those things if you're using an API key or something of that front, as well as you can specify YAML directly, and then with like the file function, pass that in. Those are some of the ways that I've seen. Do you have any recommendations on that front, either of you, in terms of what you've seen as best practice or ways to go about spinning up those Helm charts?
I think that's a pretty accurate characterization of the different ways, Taylor. Phil, I don't know if you've heard from users in terms of patterns that they've been using.
One thing I've constantly been amazed by are the ingenuity of our users. And so while you can use sort of the YAML values file, and you can use set and set secure, that is by far not the only way you could potentially go about this, but those are the paths that we intend for you to use to set the values within Helm. As for what is best for you, it really depends on your workflow and your environment, right? If you're using Helm today, right, and you have all your value YAML files already set up, and you're transitioning to Terraform, then you probably want to use the value file at least as a bridge for that, if not as your pattern going forward, if you're comfortable with that. If you're starting anew, right, and you're working with Terraform and you're working with Helm, then the set pattern may be the appropriate one for you, because everything will be in the same file and it'll be very apparent.
Absolutely agree. I think that when I have typically my workflow kind of mirrors that too, where if I've just got a couple values to set, I'll just use the set blocks, or I'll kind of I'll intermix that. If I have a whole bunch of YAML values that I want to do, I'll just use file there and set it that way, and then set some sensitive or set some other things in that front, things that I've computed from other infrastructure that I stand up. But yeah, I can only imagine what you've seen and how creative some people have been. Hopefully, it doesn't involve Google Sheets or any kind of crazy permutation like that. One other thing that is in the Kubernetes ecosystem that I'm really enthused about is the Terraform Cloud Operator. And really would just kind of, for those that haven't heard about it, do you care to kind of explain it a little bit more and what the intention is for using the Terraform Cloud Operator?
Sure, yeah, I'd love to dig into this. So the Terraform Cloud Operator is a Kubernetes operator that interfaces with Terraform Cloud. And so you're gonna, I think we're actually gonna get into a little bit of a surprise demo here on this, but to set the stage, right? So Terraform Cloud allows you to define your Terraform configuration in your version control system like GitHub, right? And then it will programmatically run, plan, and applies, depending on how you have it set, when you push new configuration to that repo. So you keep your Terraform configuration in version control, which is a best practice, but Terraform Cloud allows you to continuously deploy that when you update it. And what the Terraform Cloud Operator does is it allows you to do that from inside Kubernetes. And so we implemented a custom resource definition that and a controller that interfaces with Terraform Cloud, so that when you apply a custom resource, the operator will create that workspace for you in Terraform Cloud, connect it to your VCS repo, apply the configuration that you have in that VCS repo, and then return the outputs back into Kubernetes as a secret. And so if you then mount the secret to your deployment, you could, one, you have access to that secret in your application, but two, if you push changes to your VCS repo, the operator will actually pick up those changes from the output. And again, if you've mounted it and not used an environmental variable, then if you have your app set to watch for that event, the secret update, you can actually pull in those changes and act accordingly. Yeah. So that is that, and that's just one feature in the Terraform Cloud Operator, but this is sort of the GitOps workflow that the operator enables. We have a bunch of other really cool things in terms of, like, we allow you to use the Terraform Cloud agents and some other interesting things as well that I think Arit, you may want to get into a little bit.
Sure, yeah. The Terraform Cloud Run agents are kind of cool, actually, because they're specifically designed for on-prem infrastructure where you can't really expose your cluster out to Terraform Cloud. And so I think the demo will make this a little bit more tangible, because you can actually see how it works and how it all connects together. And I think we have a blog post coming that outlines some of the cool features that the operator has, and that might be relevant to your workflow. Does that mean we're jumping into the demo, Taylor? Is it that time?
Yeah. Just about. I've got one more question in the chat that I want to bring up. I've got a personal question, really quick to jump into before that,
Sure.
and then we're good for live demo.
Okay.
One of the questions is one of the users was asking about Terraform compliance and policy as code, and then asking some clarifying questions. They kind of reshape their question to be, what are the benefits of using something like TerraGrunt if we can get all the things in Terraform? And I think that's a great question. When it comes to Terraform, that's what we're looking to do, is integrate as closely to your workflow and your use case as possible. And so if there's anything that, I think that for a while, TerraGrunt really helped when Terraform was at like 0.10 and 0.11, when we were still kind of working through state and trying to figure out the best ways to instantiate that and allow for users to use that. TerraGrunt kind of going about the fashion of being able to declare multiple different states and interact with a lot of things at the same time. Now with the latest versions of Terraform, we have things like for each and depends on, and you can use that at the module level. So I'd say if Terraform can do what you need it to and what you're looking for it to at that level, then I'd say that's fantastic. That's kind of what we've set out to do. And then reducing the complexity. When you introduce a tool on top of another tool, you're always going to introduce some entropy and some uncertainty, just because it's, with anything, if you've got one thing stacked on the table, it's a lot harder to knock over. And if you keep stacking things on top of that, it does get more and more difficult to manage. Not that you can't do that, but it does become a lot more to manage and to be concerned about. So to answer your question, the benefits are, that you're able to get your work done, and that's a fantastic thing, without including those extra dependencies. But feel free to ask any more questions if I didn't cover that. Cool. The last question I have for you, Phil and Arit, are what are your favorite ways to spin up a Kubernetes cluster to test with or develop on? I think I might have an inkling as to what they could be, but I'm really curious to hear.
Yeah, so I'm going to be probably not very controversial here, but in terms of like, hey, I want a quick environment, I want to check something out, right? I just use kind, and there is a Terraform kind provider, and so I can do that right in Terraform, which is pretty awesome, because when I apply, it creates the cluster, and then when I destroy, it cleans it all up, which is super great. Of course, that works. That pattern obviously works with the cloud providers as well, but I don't have to wait around for a cluster to be spun up, which does, when you're just trying to test something out real quick, does add a considerable amount of time. So I find myself using kind very, very often.
Yeah, I'm the same. I mean, I switch between Minikube and kind depending on the computer I'm on, but I actually like testing on the cloud clusters, because it just gives me the feeling that I'm in an environment that's kind of reflecting our users' environments, and so I tend to have a running cluster during my workday, and then I spin it down, and so. If you do want a simple configuration to test the provider against, or to test your configurations against, there's a test infrastructure folder on the Kubernetes repository that you can check out. That's the infrastructure we use to run all of our acceptance tests. And that's what I use for manual testing as well, typically. It's very simple to bring up. It's just one apply command. You just need to provide your cloud credentials to get it spun up, and I think it costs maybe $7 to $10, something like that, for an entire day.
Awesome. I think that it's I'm very much the same way. I really enjoy using kind. Also, it's in the name. You can tell it was made with care. I like how declarative it is, such that you can, and being able to use those later versions of a Kubernetes cluster or distribution, I think are really helpful. And then I'd say the only gripe I have about that is that you do need to, if you're looking to expose some services, you have to put something on. You have to instantiate like Metal LB or something like that, and that it has a little bit of a learning curve to it, but ultimately worth it, because it makes it quite nice to use. And then managed services in just about all the major clouds, I think, are really nice to just kind of pull down and to use as well. Awesome. We do have some more questions, but for now, I would love to turn it over to you two for the live demo, and then keep the questions coming. We'll absolutely get to them, and then hopefully this demo spurs some more questions as well.
Okay, great. So I'll get started with the demo, and then the way we've talked about it, Phil will take over to talk a little bit about what we're showing. And let's hope that the live demo gods are looking kindly upon us today. Okay, do you see my screen?
Yeah.
Okay.
Yeah, that looks
Sure do.
Okay, perfect. So I've got my terminal here. I've already got a Kubernetes cluster set up. So you can see it's version 118. This is actually a cluster I set up with the test infrastructure config, and so this is a Google Cloud cluster. And I've got three things on the right here in tabs. So the first is that I have an organization already created in Terraform Cloud. And this organization doesn't have any workspaces right now, but I have gone through and connected it to my GitHub account, which is my VCS provider. And in my GitHub account, I have a very simple Terraform module called the Terraform null resource example. It's a root level module. And if you look into the main.tf, you can see that it's just a random pet resource that generates a random pet name of a specified length. Currently, the length specified is 4. So this is going to generate a pet name of 4 names hyphenated together. I also have the Terraform Helm chart for the Terraform Cloud operator in another tab here. This is the repository that contains this Helm chart. HashiCorp actually offers Helm repository here. So you'll see that currently Terraform Helm doesn't show up here because we're currently still in the beta stage, but once we become generally available, you'll see that the repository for Terraform Helm shows up here as well. In order to install the Terraform Cloud operator in your Kubernetes cluster, there are a couple of prerequisites. You need to create a secret called Terraform RC. That contains the credentials for accessing your Terraform Cloud organization. And if you want to pass any secrets into your workspace configuration, you need to create a secret called Workspace Secrets that has the key value pairs that you want to pass in. Okay, great. So if we head over here now, I've got a namespace, a demo namespace for us to work within today. Not sure why it's taking a second. Oh, there we go. So I've got the demo namespace, and I've actually already created the 2 secrets that I just mentioned. So you can see I've got the Terraform RC and the Workspace secrets both created already. So I'm able to connect to Terraform Cloud. So in order to install the Helm chart, we're just going to do what's recommended here. We're going to do a Helm install. We need to use the devel flag because the operator is still in beta, but you won't need that anymore once we're GA. I'm going to install it into my demo namespace, and I'm just going to use the name operator instead of generating a name. There we go. Okay, so it looks like the operator was successfully deployed. You can see that it was deployed into the demo namespace and that the release is named the operator. So if we get the pods that are running in the demo namespace, you can see that the operator Helm chart has created a pod. It's running and available to go. So we can go ahead and try to create a sample workspace. Another thing that this Helm chart does, and I think Phil spoke to this earlier today in the call, is it creates a CRD, And so the workspaces.app.terraform.io CRD allows you to create workspace custom resources. And you can feel free to modify that CRD to your needs, but it should have reasonable coverage of the available features of the Terraform Cloud API. Okay, great. Today I'm going to show you the VCS configuration step that the Terraform operator allows. So I've already got the VCS connected to my organization in Terraform Cloud, but we want to create a workspace and we want to be able to access the outputs of that Terraform configuration in Kubernetes. So if you check out the Terraform Helm repository, the Terraform Helm chart repository, you'll see that it has an example folder. And if you go into that example folder, you'll see a bunch of different YAML manifests that are examples of the things that the operator is capable of doing. So you can see that there's one for the Workspace remote agent that we talked about earlier that allows you to configure Terraform Cloud Agents for your on-prem setup. We also have Workspace VCS, which is what I'm going to show you today. So if I cat the Workspace VCS YAML manifest, you can see that I've already modified it for the purpose of this demo. So this is a Workspace custom resource based on the Workspace CRD. It's named VCS. It's going to create a workspace in my strategic integrations Terraform organization. It's going to connect the module Terraform null resource example that we talked about here. And the token ID here comes from our VCS provider configuration. So we just take this token ID and drop it into the Workspace manifest. Great. Yeah, I don't think there's anything else of note in this YAML manifest. So we can go ahead and apply this. And see what happens. So it looks like the workspace was created. So if we do kget workspaces, oops. You can see that the VCS workspace was created 12 seconds ago. And on the right, you can see that the corresponding workspace was created with the pattern namespace hyphen workspace name. And so if you go in here, you can see that the 3 steps have succeeded. So Terraform has planned the configuration that was in our repository. And it said, OK, I'm going to create a random pet name of length 4 with the separator hyphen. It ran through cost estimation, and it created these 2 outputs. Now, the cool part of this integration is that you can actually access these outputs from Kubernetes. So if you get the secrets in our demo namespace, you can see that there's this new secret called VCS outputs. And if you take a look at the VCS outputs, the contents of VCS outputs, oh, oops. If you take a look at the content of VCS outputs, you can see that it has the same 2 pieces of data that are in our apply outputs here. And if we were to actually inspect the values in here, you can see that there are these 2 base 64 decoded values. And if we decrypt them, you can see that their contents exactly match what is reflected in Terraform Cloud. So yeah, that's pretty cool. So essentially now you can consume these outputs in whatever format you want, another resource, an application, and use it wherever you need. And so let's see what happens if we make a change to this configuration here. So let's say I change this to 6. I got a code review from Phil. And I commit that. And so if we head over back to Terraform Cloud and check out our workspace, you can see that a new run has been queued based on my update. And this run is planning. You can see that it's going to switch the length of our random pet name from 4 to 6. And it's generated these 2 new outputs based on our changed configuration. And so if we go back here and we take a look at our VCS outputs, I'm hoping that the outputs have been updated. Uh-oh, I did that wrong. Hang on. There we go. So you can see that once the changes were applied in our configuration in GitHub, Terraform Cloud picked up those changes. It ran through the 3 steps of plan, cost estimation, and apply. It created new outputs, and the Terraform Cloud operator put those outputs into a secret in Kubernetes for consumption. And so this is essentially the most powerful part of this Terraform Cloud operator integration, is that you can make whatever changes you like in GitHub, go through your typical development process, get a code review, get it merged. Terraform Cloud's going to pick it up, apply it to your infrastructure, and then your infrastructure is going to be able to use those outputs in whatever application you need. Yeah, and I think that's pretty much it. I could also show you what it looks like to clean up this workspace. So let's say that you're done and you want to go back to the start phase. We can just delete the workspace by using the original configurator. Oops, wrong namespace. So while you're cleaning up, actually the Terraform operator will wait until Terraform Cloud gets back and says, hey, the workspace was successfully deleted. So we're just gonna have to wait a second. You can see that the destroy is actually being planned here. So it's being queued, and it's gonna go through its process. There you go, it was destroyed. And so this should disappear in a second and the operator will exit. There we go. And yeah, so I think that's pretty much it for the demo.
Awesome. Thank you so much, Arit.
No problem.
If anyone has any questions for Phil or Arit on the Terraform Cloud operator, please feel free to surface those. Otherwise, I've got a few other questions to bring in. Anything else that you wanted to say about the Terraform Cloud operator, or any other plans that you have for fun features or things coming up?
Yeah, definitely. Thanks, Taylor. So great job on the demo, Arit. That was really good. A couple things I want to highlight about that, right, is you saw Arit go through that. He used Helm, right? He used YAML, right? He could also have used Terraform, right, with the providers that we talked about earlier, right? And so this is an area where, we are living our philosophy of workflows and not technologies. So if you like the Terraform Cloud operator and you want to use it, but you want to continue to maintain your Kubernetes YAML manifests, and maybe adopt the Kubernetes provider for some or none of your configuration, right? That doesn't preclude you from using the Terraform Cloud operator for your infrastructure that is external to Kubernetes. And that's really what this is all about. Or, in turn, right, you can actually use the Terraform Cloud operator as essentially a Terraform GitOps engine for Kubernetes, right? And you can specify all your Kubernetes workloads in HCL using the Kubernetes and the Kubernetes Alpha provider. And you could have the operator merely, provisioning these workspaces and then deploying back into Kubernetes for your own applications. So there's a lot of possibilities, a lot of workflows to accommodate what you need in your infrastructure that the Terraform Cloud operator for Kubernetes really enables for you. So that's what we're really excited about. And we're, like Areet said, we're getting ready to go GA at the end of this month, and you'll see that demo in the blog post that we're going to produce as well, and as well as with some follow-up content about how you can use the Terraform Cloud Operator with other Git engines like Flux and Argo, and really how they work very well together for Kubernetes and your external infrastructure.
There was a great question that came into the chat a little bit before the demo that I thought was really kind of, you really spoke to that point. The question was, I believe delegating tasks for deploying things into the cluster via CI/CD pipeline would be a better approach than using the K8s provider. Rationale behind this is that you could still reuse the YAML. Any thoughts? And so, kind of like you both illustrated, you can, depending on what workflow works best for you, you can use whatever, kind of permutation or lineup of tools that best fit that workflow. This abides by a really nice GitOpsy type of workflow, and you're still able to use, certain aspects of Terraform and the Kubernetes and Helm provider and kind of line up your workflow that way. Like Phil said, there have been a couple items that I've spun up just recently, like using Flux. What does it look like to use Terraform to spin up a Kubernetes cluster, install Flux, and then rely on that to handle the application deployments? We're very much focused on workflows, and so we don't feel like it's only this way or nothing else. We really want to enhance your workflow, no matter what that might be, and really want to stress that point. So if there's anything that you think that we could you'd like to see, or that you'd like us to hit upon, or kind of give some more thought to or words to, we'd be more than happy to do that. Hope that answers that question, Vinay. There was another question as well around, we got a question for someone that has a COPS stood up cluster, and they're looking to migrate to EKS, and ways that Terraform might help with that. Answering that first, I'd say, so Terraform, it kind of like with CI/CD and all of these other processes, Terraform kind of operates a very specific space, and that is, declaratively calling out and standing up your infrastructure. It could be used as a shim, but only in the case of being able to stand up your EKS cluster. And then if you want, you can then, kind of call out, do you want to use Terraform to manage your deployments and your configuration, and different ways that you want to go about setting things up. But in terms of like a Kubernetes migration tool, I'd say it's not really the space it's meant to operate. I'd say that, there are a couple projects out there, like Arc, I believe, is a really good one if you want to like back up your Kubernetes cluster and then shift that elsewhere. Have either of you seen some really good examples of, almost like Kubernetes migration services or anything like that? I think mostly it's just been like get it as infrastructure as code, and that does make it easier to transition over.
Yeah, I don't know that I have anything like really compelling to add on top of that, Taylor. I will agree, like using infrastructure as code as your operating model really sort of enables this, because it's very clear to you what exactly exists because it's in your code, and then what needs to exist on the other side. Yeah.
And then one other question is, best way to upgrade the AWS EKS version using Terraform? I would say really just taking a look at the resources, if on registry.terraform.io, taking a look at the AWS provider. If you go to the registry, not only do you get to see all of the different providers that exist within Terraform, but once you start looking into one of those providers, you're then able to filter things down, use that fuzzy search option, which is really fantastic. You can see a module that might fit your use case, as well as introspect the documentation and filter out all of those resources and data sources as well. So I definitely recommend taking a look at that. There are some modules out there for EKS specifically that make, you just change the version of your Kubernetes cluster, and that makes it really easy to upgrade on that front. Again, one thing that we talked about earlier is making sure that you separate, your control plane and that instantiation from your configuration. Otherwise, you can run into some edge cases there. But yeah, I'd say that's probably the best way to go on that front. Awesome. And then we have another question: best open source tool to monitor for Kubernetes, leaving Prometheus and Grafana.
I'd like to turn that over to you two. I'd say that I've got a lot of experience with Prometheus and Grafana, and again, standing it up as infrastructure as code is going to help me with, adjusting on that front. But that and Datadog at a few companies as well.
Yeah, you stole my Datadog plug there, but yeah, that's mostly what I've seen. Yeah, I can't really think of others that I've got experience with.
Yeah, I mean, just on a personal level, right? Datadog is not an open source tool, but it is a very compelling one for the Kubernetes use case, and quite mature. Leaving aside Prometheus and Grafana makes it a very difficult question because they basically are the de facto standard for Kubernetes monitoring. I will say, while I haven't monitored Kubernetes with it, I do have some experience with InfluxDB, and I have had really good experiences with that. And my understanding is you could use that as a Prometheus replacement.
It's really interesting to see what people come up with in that space, especially around, well, like one thing, again, Datadog's not open source, but I really do like the monitors that will let you know if no data has been consumed. I think that's always one of the fun questions that people get posed, is what happens if your monitoring software goes down, or if it's running in the same cluster or something of that nature, and kind of adjusting for those types of events. But barring all of that, I think that those are really Prometheus and Grafana are really fantastic tools for keeping an eye on things, and then Alert Manager for kind of letting you know what's going on and what's happening with your cluster, whether that be Slack or email or however you get alerted on that front. I haven't been on a 3 a.m. call in quite some time, thanks to some of these tools, and hope that doesn't happen anytime soon. But awesome. Well, if we are nearing the top of the hour and we're going to be closing out soon, so if you have any final questions, feel free to put those into the chat, and we'd love to address that. With that said, unless we get any more questions, are there any parting words that either you would like to give, or anything that you're excited about within the Kubernetes ecosystem that you've got your eyes on?
Yeah, so one, I just want to double back and echo what Arit said earlier about there being a sticky issue on the alpha provider, as well as my Calendly link there. I would love to hear from you, or if you have direct feedback or feedback that you would like to deliver to me directly. I am your interface to HashiCorp engineering for Kubernetes. Please don't be shy. I want to hear from you. I enjoy talking to you and hearing about your experiences, hearing about the things that are working, especially about the things that are not working. That's what I'm here for. So please take advantage of that. Things that I'm excited about. Oh, there's so much I'm excited about, Taylor, even like excluding all the things we talked about today, which I think are really exciting. We touched on Flux earlier, right? There's a Flux provider in the Terraform registry. Check that out, right? That is a very interesting way to get the new Flux version up and running in your cluster, and I think quite compelling. I think in the not so distant future, this is, I don't want to let too much out of the bag here because we're not committing to this, right? But we're really looking at how do we expand the Terraform, let's say CNCF ecosystem, right? And we're looking at things like cluster API and what that could mean for Terraform, as well as a lot of the other projects. And so if this is something you have an opinion on, again, I'd love to hear about it. So please don't be shy. Come let me know.
That's a great set of callouts. I think in addition to that, I would say I'm really excited for the maturing of the Kubernetes alpha provider into the final form that it becomes. I think that it's going to be pretty powerful to see the community start to build modules for the various YAML manifest-based deployments they're doing right now, and see what that could look like and which ones become popular and become de facto ways to deploy some of that infrastructure.
Awesome. I'm really excited for I've got my eye on quite a few things as well. I'm really kind of curious to see how kind keeps getting kinder with some of the features that they have set up for things, and then obviously with every Kubernetes release, I'm quite excited to see what new things get added and what things move from alpha to beta to GA as well. One piece of news that we have for you is HashiTalks. opens up next week, starting on, I believe it's the 17th and 18th. We used to be a 24-hour event, and now it's expanded to 48 whole hours based on all of the awesome CFPs and just really fantastic, really difficult to narrow those down. So we just decided to add a day. We'll drop the link in the chat here shortly in terms of some talks that look really compelling on that front. I did see some in there about logging and monitoring. I think our very own Nick Jackson is going to be talking about using Flagger and Console and some really cool ways to release your applications. I'm not sure if you've seen the lineup, Phil or Areet, if they're excited about any of the chats that are coming up on that front. But if there are any, definitely would love to hear any that you're excited about. But I saw a few Kubernetes ones in there that got me pretty stoked.
Yeah, there's one particular that caught my eye, Taylor, and it's on the second day. It's called Building Reliability in the Kubernetes Using Chaos Experiments with Terraform. That one looks really interesting, and I've candidly, I have no prior knowledge of like how that is actually going to be delivered, but it looks like super intriguing. I can't wait to see it.
Yeah, I actually think it would be kind of cool to see what all the other products are doing with Kubernetes as well. And there are a couple of talks about console connected Kubernetes and so on. So I'm pretty excited.
Awesome. So with that, would like to draw everything to close. I did think that there was one last question in the chat, but I'll feel free to reach out, Saket, or I'll try and find the documentation. The question was, are there the changes between Terraform 0.12 and 0.13? We do have that in our, if you go to terraform.io, we do have that in our documentation, and just some considerations for jumping between versions, whether you're going from 0.11 to 12, 12 to 13, 13 to 14. We do document out, what are the considerations between each of those changes. So please make sure to check that out. The final link that I have to share with y'all is we did just put out our latest Hashi Talks podcast, where myself and coworkers Tracy P. Holmes and Kareem Satirli talk about what it is to be a developer advocate, what it's not, some fun stress baking recipes that we walk through. They all sound delicious. I can't wait to make most of those. But thank you again for joining us for a fantastic community office hours, and we hope to see you. We hope to see you when we see you. We'll talk to you soon. Thank you so much, everybody.
Thanks, everyone.
Have a good one.
Bye, everyone.
All right, I have ended the stream.